My name is Tom Pollock, and we're here to present you guys with the system rack view. Our client is Jason Brown from the Naval Undersea Warfare Center at Newport. Jason is right over there. To begin with, I would like to introduce my team. To the left of me is Alexander Neri, who's the Scrum Master for System Rack View. To the left of Alex is Austin Quinn, the front-end developer. To the right of me is Gerald Hoxa, full-stack developer, and Roman Alsheri, who's the back-end developer. So to give you guys an idea of the project and the problem statement that we were given was to fully design, develop, and demonstrate a front-end user interface of a complex distributed system, which will allow the submarine trainer maintenance crew to fully visualize and see different statuses of a system rack view from a machine and virtual machine perspective. So for the most part, as we know, trainers run very smoothly and there's no issues with them. However, if there's something that goes wrong, the submarine trainer maintenance crew has to figure out what went wrong, and they have to locate the machine. With our tool, they're able to navigate it quickly and fix the issue right away. To give you guys a physical view of what the rack device looks like, right here, we have a full rack, and inside of the rack, we have multiple devices, and each device is able to have as many virtual machines as you want based on the user's database. So the solution that we came up with for System Rack View is to be able to develop a robust, dynamic, and modular application which will allow you to display the machines and virtual machines in a rack view style. So we wanted to develop multiple functions that are clearly focused on determining the state of the virtual machines and the machines themselves. And in order to present you guys and give you an idea of what the application would really look like and how it would work in real time, we created a database simulation to show you how it's actually going to work with the user's daily usage. The architecture that we've used was MVC, and MVC stands for a model view controller. So what happens in MVC is we have a controller that sends data from the model, and it receives the data from the model, which goes back to the controller, and then for the controller, we have it sending to the view, and so forth. So it's pretty much an ongoing cycle, and the cycle just never stops.
In order to develop our tool, we decided to use the Qt SDK because Qt uses C++ and is built for cross-platform integration. Now, what that means is if you want to use this on Android or Windows or even BlackBerry, this can be handled, it can be shipped to that platform in order to be used. Now, Qt can also be run on desktop, embedded, and mobile devices. One really nice thing about Qt is that it has a whole library system set up for creating widgets and graphical user interfaces, which was important for our project since most of our project is about how we display our data. With that in mind, our first feature and our biggest feature is the widget set of our project. Now the widget set has to be dynamic enough to move across any size host. So if you only had one rack for some reason, or you had 20 racks with machines filled in all of them, our system can set up the widgets to display all of those, which is important for use when you're connecting it to your system rack. Our tool can be connected to many of those. And the other important part of our tool is the display of data. Now the display of data works in a very simple fashion. We show a maximum of 3 racks at once, where you can then scale between them, scroll between them using the scroll wheel, and a minimum of 1 rack. And what happens here is that when everything is working as intended, you should get something that looks a lot like the one we have on display here, where everything is just green across the board. Now, it is set up that way because when things are working as intended, you probably don't need to look at this tool much. However, things are not always working as intended, and when you find a problem, you may find this in one of the setups where you have the tools here. The tool of our setup here, where you need to display what may have gone wrong with your. Why does this keep finding? What may have gone wrong with your system. So what we have is a tooltip that when you hover over a machine or a virtual machine, you can see information about the state of that machine. Once again, on display here, we have one that is working as intended. So everything is online across the board. It's probably what you would expect to see if things are running correctly. Now, in order to discover what has gone wrong, we use a color scheme that would be very easy to decide upon visually what is wrong with each situation and where it has happened. When things are not green across the board, you'll see things like this. So right here we have an offline machine, and right here we have a not connected machine. The difference between those is that we wanted to represent the physical host exactly the same way you would see it when you look at the actual physical host when dealing with racks. So we have a not connected slot, as is when a machine is not placed in your physical host. There's an empty slot that you can see, and we decided to represent that with the not connected. However, obviously they don't change colors so nicely for you when you're looking at a physical host, so you have our machine tool in order to decide what may or may not have gone wrong. Now maybe you have an idea of which one of your machines has been faulted, and you have a lot of racks, and you want to find that machine quickly to see if that's in fact your problem. We implemented a filter for this exact case called the machine filter. This is at least what we call it. And what this does is by searching for the name of a virtual machine or machine, it will reduce the size of your view to whatever your search may be. So as you can see here, we have searched for SER, and we've gotten the two different machines that start with SER as the only thing displayed here. This is important for quick navigation of the tool, which is important for quickly finding your problems. Now, our search filter is located on the machine status updater. The machine status updater is a manual tool for overriding anything you may need to. So one important use of this is to degrade a faulted machine, because sometimes a machine may not or may not be working, but it's not of the utmost importance at this moment. And if you're still looking for what the problem is, you might want to simply degrade that machine so you don't glance back at it later. It'll also allow you to change any of the states to whatever you'd like, but it's not recommended since you most likely want to know what the state of your servers are. Now, in order to display our tool in action, since we don't have our own database, we created a virtual database, and we use React.js in order to update that database. So this right here is how we update our tool for our demonstration. However, it's not how the tool will be updated when in use, since it'll be connected to your server. Without further ado, we have our cool demonstration.
Close the demonstration.
All right, so what we have here is a display of both our tool and the database controller that we used in order to update our tool for our demonstration. So as you can see here, our tool has some problems. Right now, our system rag is not working very good. We have some offline, we have some faulted, and it's not great. However, let's say for some reason so this is our second device right here, and this is our fourth one. Let's say for some reason our fourth one has been fixed. Well, when it gets updated from the server, it would change its state into an operational state, which will then show you that whatever the problem has been there has been solved and is working correctly, is working as intended. Now, when we hover over that machine, we can see the tooltip.
There we go. Cool.
And the tooltip shows that every single one of these is once again green across the board. Once again, that's expected when a device is working correctly. Now, it is important to note that
we have more than one rack here actually on display. And this is the scroll wheel right here. Like I said, it has one rack minimum display, and you can scroll between them. If you was to full screen this, you would show multiple racks, in this case 2 for our display on the projector. Now, let's say we wanted to find one of the machines that is offline, like the VM host-2. By searching through here, now we reused some names for our presentation, granted, but searching through here, we have now narrowed it down to the 2 different machines that are named VM host-2. These names are not created by us, they're created by the database itself. You give these through, we have signals and slots that update our entire display and change the widgets, which we mentioned in our MVC section of how our architecture works. Now, as before, when we were looking at the whole thing, if we delete our search, it simply recreates the view of the rack that you were looking at before. Since these are offline, but we don't want to deal with them right now, maybe the server, those are offline, sorry, faulted, and we don't want to deal with them right now, maybe the server doesn't change, but we can change those manually. So if we change one of these to faulted, that's fine. And now, instead of dealing with that right now, we're simply kind of putting it off, but at least we can look for the more pressing issue that we have been faced with. So those are the main aspects of our tool in use when we're updating it. Naturally, when there are things going wrong and it's updating itself, it'll look way more important since we're just kind of fiddling with a database we created that's not really the best example of it. So that's what we have to show you though, and that is our tool.
So the tools that we decided to use for the development of our tool is Discord, Google Drive, Slack, and Outlook for communication. For version control, we've used Git, and to document all the code, we went with Doxygen. For any kind of future development work, the things we wanted to add would be an additional context menu, which is an entry to the rack view. So for example, you want to right-click a host or a virtual machine, which would be used in the same way the tooltip was used. And you would select that as a software status. Another option would be status distribution recording. So let's say one of the submarine training maintenance group members wants to follow up on what happened in the past, but they haven't seen it on their own, so they want to go back into the backlog that's been created, and they can see everything else timestamped. And lastly, we want to write a pure virtual interface for network control. So, questions?